Okay, so to start this problem, we've got to try to link together the common elements. So just to start, I like drawing a little picture for this. Makes life a lot easier. So here's her home. Here's the park. Jill runs 12 miles to get to the park. And then she runs back through a longer, hillier route, which takes her 20 miles. So that's our problem. It's split up into two separate sections. Her run to the park and then her run back from the park. So what do we want to know in this problem? We want to find Victoria. We want to find Victoria's jogging speed. So we're going to call the on the flat trail. So we're going to call this the speed on the flat part, which is equal to x, because that's our unknown and it's what we want to find. And then that means we can also start identifying that, say, we're told that she jogs 1 mile per hour slower, so we can say that her speed through the hilly section is equal to x minus 1, because it's a little bit slower. And then we have these other distances. So 12 miles is the distance along the flat path, and 20 miles is the distance along the hilly path. And the last part of this is going to be to link these two trips. So how are they linked? They're linked by the fact that her return trip takes 2 hours longer than her initial trip. So the green trip along the hilly trail takes 2 hours longer than the flat trail took. So that means that the equation looks something like this. The time to do the hilly trail is equal to the time it takes to do the flat trail, t flat, plus 2 extra hours. So that's how those two equations are related. Time to complete the hilly trail is equal to the time to complete the flat trail plus 2 extra hours, because it takes longer on that long, hilly, slower trail. Now I can go ahead and put in my times, replace my times, I should say, with speeds and distances. So time is equal to distance over speed. So the time to do the hilly trip is the distance of the hilly trip over the speed of the hilly trip, which is equal to the distance of the flat trip over the speed of the flat plus 2. And now putting in values that I know, that would be 12 over x minus 1. And, distance of the hill, that should be 20 over x minus 1. I'll erase that and fix that. 20 over x minus 1. And the flat trail is 12. And the flat speed is x plus 2. So there's my rational equation. The hard part of setting it up is over. Now I go ahead and solve. To get rid of denominators, multiply by x times x minus 1. And then multiply that into each. So 20x there. Then I have 12 times x minus 1 plus 2x times x minus 1. 2x squared minus 2x. So another quadratic. Let's take this 20x over to the left-hand side. So I have 0 is equal to, well, I have 12, so 2x squared. And then my x's, I have 12x minus 2x minus 20x is all minus 10x, and then minus 12. And I can factor out a 2, which is great because it's going to turn this into a simple trinomial. That's going to make my life a lot easier. So I'm going to factor 0 equals 2 times x squared minus 5x minus 6. So that would be 0 equals 2 times simple trinomial should be x. Two numbers that multiply to negative 6, add to negative 5. This has got to be negative 6 and positive 1. So x minus 6, x plus 1. So solutions would be either x equals 6 or x equals negative 1. I will reject the negative answer because can't have a negative speed, which means x, the speed on the flat trail, would be Victoria jogs at 6 miles now, because all these distances are in miles and our times are in hours. So that would be 6 miles per hour on flat ground. Excellent. And that's what it takes to solve that problem.